All right, we're going to take a look at the homework from chapter 4 here, part 2. So, just the middle of the chapter there. So, I'm on page 4-21. And this was around this closed traverse, sort of moving through here and identifying bearing and azimuth angles. So, I'm going to go through this in some detail. As always with angle reasoning, there's more than one way to get there. So I'm going to show you the method that I used or the angles that I looked at to find the answer. But you could have, used some other geometrical angle and figured out that measurement or added together different angles. It's not just one way to do this. There's multiple approaches to this, but I will show you mine and you'll have that information at least. So to start off here, we're going to look at bearing AB. So from A to B here, and we are given this information, but I'm going to go ahead and draw on our axis. That's something that I always do as I'm looking at these forward bearings and azimuths, just so I know what I'm talking about and where it's being measured from. So the info I'm given here is the forward bearing. So that's coming from the north and going to the east. So for my little coordinate I drew here, that's my north line, that's my east line. So this angle is measured coming from the north, going to the east until it hits this forward bearing AB. So my directions are there, part of my bearing measurement coming from the north, going to the east, and then the angle measurement is the 50 degrees and 15 minutes. So again, given to me. Also, I'm curious about the azimuth formed by this line AB, and that is going to have that same measurement. Remember, azimuths are always measured from the north and then going down to the line. And so in this case, and clockwise. So in this case, that measurement is the same as the bearing. It's that 50 degrees and 15 minutes. So done with line AB. So we'll move over to line BC next and figure out what its bearing and azimuth is. Again, I like to draw the coordinates on here just so I know and kind of identify what I'm looking for. So I can see how this all pieces together as I find that info. So as I look here, I can see that right off that my bearing is going to come from the south and go towards the east. All right, so it's coming from that south and going towards the east on that coordinate grid. So I'll go to put those locations in here, south and east. And then I can see my azimuth up here at the top, going to come from the north past that 90-degree line all the way down, a little bit past that, down to my line BC. So let's think about this line BC and how to compute some of these values. I know this whole interior angle here is 127 degrees and 11 minutes. And from my angle reasoning, I'm going to use the fact that, if I look at these two grids together, they make this rectangle of 90-degree angles. And so if I'm looking at alternate interior angles, then I can know that this angle is the alternate interior angle to this one. This measurement is 50 degrees and 15 minutes. So this one is 50 degrees in 15 minutes. Just kind of a quick thing that I can do to see those equivalencies. So that will let me figure out um, what the measurement of this other part of this 127 degrees and 11 minutes is here, which is actually the value for my azimuth there. So I'll put this over to the side here. So I'm on this line BC. I'll start with the azimuth there just because I can see it right there, right? It's part of this 127 degrees, 11 minutes. And the other part is this 50 degree, 15 minutes. So I'll just do that subtraction there to figure out what that azimuth is. So 127 degrees, 11 minutes minus 50 degrees, 15 minutes. I'll need to borrow here a degree. That's 71. And so this becomes 56 minutes. 126 minus 50, 76 degrees. So that's my azimuth measurement in there, 76 degrees, 56 minutes. And again, we said that's coming from the south, going to the north, going to the east, not to the north. So bearings can come from the north or south and go towards the east or west. They have to be only in one quadrant. They're less than 90 degrees. Azimuth, on the other hand, always coming from the north, always going in a clockwise direction. So in this case, now that I know what that bearing is, I can see, right, I've got my straight line here, my north-south grid line. That's going to be 180 degrees. So to find this bearing for line BC, I'll take that 180 degrees and I'll subtract that 76 degrees, 56 minutes. That's the bearing, and also just that part that I don't need for the azimuth. So I'll go ahead and borrow here. I'll make that 79 and this becomes 60. So this becomes 4 minutes and 103 degrees. So my azimuth 103 degrees and 4 minutes. All right, all the way over to line CD. So I'm going to go ahead and put my coordinate grid here at C and try to figure out what's going on there with an azimuth and bearing. All right, here I can see this is going to be a big azimuth, right? Because I'm starting at the north and I have to come all the way down to this line CD. So more than 180 degrees for that azimuth. But my bearing's going to be a little small here. If I look at my south line, right, I can see in order to get to less than 90 degrees from the north or south, it's going to have to come from the south and go towards the west there. So this will be south and towards the west for the bearing. And I know information about this whole angle here. This is going all the way up to the line and down here to this line here is 92 degrees and 35 minutes. Okay, so just trying to figure out, what do I want to look at first here? If I go ahead and complete that rectangle again between coordinate grids like I did last time, I've got my 76 degrees, 56 minutes here. Well, then that also becomes the measurement of this angle, right? Alternate interior angle. So this is also, I'll do it in the same color. This is also that 76 degrees, 56 minutes that we found before. So we can see here that if we take that angle and add it to this angle, um, and then we took that whole thing and subtract it from 180, we can figure out what that little angle is in there, also known as our bearing. So I'm going to go ahead and do that. So I'm here on CD. I'll put that over on this side. And I'm starting off trying to figure out what the bearing is this time. But I have a couple steps I'm going to take to figure that out. The first step is I'm going to add this angle and this given interior angle here. So I'm going to add that 76 degrees, 56 minutes, and I'm going to add it to that 92 degrees, 35 minutes. So that's my first step there. I figure out what this whole big angle is here, and then I could subtract from 180 to find the little one. That's one approach to take. That's what I'm going to do. So this is 91 minutes. This is 168 degrees. So we can roll that over to become 169 degrees and 31 minutes. So those are equivalent. So now I figured out this whole section here. I want to find this little piece in here. So I'm going to take 180 and subtract that 169 degrees, 31 minutes. I got to borrow here. So that'll become 179 degrees, 60 minutes. This will become 29 minutes and 10 degrees. So that little bearing in there is 10 degrees, 29 minutes. And we had already sort of discussed where it was starting, where it's ending, starting at the south, going towards the west. Well, once I know that, the azimuth becomes pretty easy. And you could have done the azimuth first. Again, lots of different approaches here, but continuing with CD now, that azimuth just becomes 180 plus that little bearing part. So it's 180 plus the 10 degrees, 29 minutes. So 190 degrees, 29 minutes for the azimuth. All right, halfway there. So let's go to DE here. Put my coordinate grid at D. All right, again, what am I looking for here? I'm trying to find a bearing and an azimuth. So for my azimuth, again, I got to start at the north. So I'm going to come all the way around to here. But again, for the bearing, I'm going to be coming from the south and going to the west. So same thing, I'm kind of turning the same way in that traverse. So not too surprising there. Starting from the south and going towards the west here at line DE. So again, I'm know an interior angle here, and just sometimes these don't get drawn in all the way. So that's all the way this interior angle that I know, 134 degrees and 30 minutes. Again, I've got my information from my previous angle, so I did figure out what that bearing was, that 10 degrees and 29 minutes. So if I think about that alternate interior angle reasoning, this angle then is the same, right? It's going to have that same measurement of that 10 degrees, 29 minutes right in there. Write that in here. So I can see if that can help me. I can see that this whole line here, this azimuth then, is going to be basically that whole 360 degrees except for the 134 degrees 30 and that 10 degrees 29. So that's one way to approach that. I could also go ahead and subtract that 10 degrees, 29 minutes, and then kind of try to figure out what that difference is from 360. So I think I'm going to go ahead and do it that way for DE. So let me put that down here. Slide it down a little bit. DE. So we're going to go ahead and start off by finding the azimuth. All right, so I can see that azimuth comes all the way here, except it does not include this whole piece of this angle and that bearing that's part of that. So first I'm going to find out how much this interior angle is without that bearing. So I'll take that 134 degrees, 30 minutes, and subtract off that little piece there that has that same value from before, that alternate interior angle of 10 degrees, 29 minutes. So this becomes 124 degrees and 1 minute. Right, so that's that whole angle here without that little piece. So now I can find that azimuth by taking 360 and subtracting that whole angle without that little piece in it. So now we'll take 360 degrees and subtract 124 degrees, 1 minute. Again, got to borrow here. This becomes 359 and 60. And so 59 minutes and 235 degrees. All right, so that is my azimuth for DE. 235 degrees and 59 minutes. All right, and again, I found that using the alternate interior angles, I knew this small angle here from that bearing of CD. So I knew that that small angle had to be the same measurement. I subtracted that small angle measurement off from this total interior angle. And then I can figure out that azimuth by taking 360 and subtracting that piece that's not part of the 360 degrees. But I still need to find this bearing here, that little piece. And so I can say, well, if this azimuth is going all the way to here, the bearing is just part of that. I can take that bearing and then subtract 180 from it to find the azimuth. So, or to find the bearing. So I'm going to go ahead and do that for my bearing for DE and take that 235 degrees, 59 minutes, and subtract off that 180. Let's kind of subtract off that straight line there. So I'm just left with that smaller piece. And that becomes 55 degrees and 59 minutes. And we had already talked, that's coming from the south, going towards the west. So south 55 degrees, 59 minutes to the west. Again, you could have solved for other angles, put other pieces together, but this is just one approach that I took. All right, let's go on to line EF. Put my coordinate grid there. All right, again, where is my bearing? Where is my azimuth here? So I'm going to go ahead and take a look at what's happening here from my line. Remember, I am going to EF. So don't get yourself confused here and go down to DE, which would be back bearing ED. We want to go all the way around to EF. So if I'm starting here at the north for my azimuth, I'm coming all the way, all the way, all the way, all the way around to that line. All right, for my bearing, I have to come from the north or from the south axis, and I want it to be less than 90 degrees. So used to coming from the south there, but take a look. We're going to have to come from the north this time in order to get it to that less than 90 degrees. So from the north to the west direction this time, north to west for that line EF. Okay, so now I know an interior angle measurement here too. This is 134, 42. I also know this bearing, right? I figured out this bearing before was 55 degrees, 59 minutes. So if I use my interior angle reasoning here, I'm just going to go ahead and put this angle in here. Those two are equal, so this is also 55 degrees, 59 minutes. And think about, can I use that to help me figure out any information here about that azimuth or that bearing? And again, I can use a similar approach to what I used last time. I'm going to go ahead. So now I am at EF here. For EF, with that 134, 42, and 55, 59, I'm going to go ahead and subtract that 55, 59 from the 134, 42 so that I can figure out what this piece is right in there, and that will tell me that bearing. All right, so I'll take that 134 degrees, 42 minutes, subtract that alternate interior angle, 55 degrees, 59 minutes. Have to do some borrowing here. We'll make this 33, and then this becomes 102. 102 minus 59, 43 minutes. 133 minus 55, 78 degrees. So I've just gotten rid of this piece and I'm just now left with the bearing. We said that's coming from the north, going towards the west. So that's the 78 degrees, 43 minutes. All right, so that was the bearing. We'll label that bearing calculation there for EF. So let's go ahead and find that azimuth now. Put it underneath. So just again, I can look at this and see what's happening there. If I went all the way around that full circle, that's 360 degrees, but I'm falling short by not using that bearing. So to find the azimuth, I'm going to take my 360 degrees and subtract that 78 degrees, 43 minutes. Again, I'll borrow, becomes 59 and 60. So that's 17 minutes, 281 degrees there for that azimuth. So 281 degrees, 17 minutes for EF. All right, last one here. We're going to come over to F and draw our coordinate system there. And label bearing and azimuth. So for my azimuth, again, I've got to come over to this FA line. So starting from the north, oh, it goes all the way around to there. And then that bearing line, remember, it has to come from the north or the south, has to be less than 90 degrees. So this is going to have to come from the north and go in that west direction again. So north and west there for that bearing. Okay, and again, I know that interior angle, and that spans that whole section there. Is that 115 degrees, 51 seconds. I remember here, I have some information from what came before because I had found that bearing to be 78 degrees, 43 minutes, so alternate interior angle. I can know that this is 78 degrees, 43 minutes. So draw that coming from here. All right, so I'm going to go ahead and take that information and pull part of that out again, just like I did before. So if I take a look here and I take out that 78 degrees, 43 minutes, and figure out what that distance is from 90, I can find this little piece of the angle. I can also take that 115.51 and think about what's going on up here. So I can look forward also and think about that since I'm kind of coming to the end here. So if I remember back to AB, I knew this was 50 degrees, 15 minutes. So if that's true, then I can see what this angle is in here. So I might use my information behind me and in front of me here. So I'll do this last one at the bottom. So this is FA. So let's figure out what that missing angle is first. So that would be 90 degrees minus that 50 degrees, 15 minutes. So that becomes 89, 60. So 39 degrees, 45 minutes for this angle. 39 degrees, 45 minutes. All right, if I know information about that angle, that can help me as I look forward here and think about how this full angle is broken up. All right, so I'm going to take that 115.11 and subtract that 39.45 to figure out what that small angle is in there. So Now I take 115 degrees, 11 minutes, and subtract 39 degrees, 45 minutes. Borrow here again, 4 and 71. So it becomes 26 minutes, 75 degrees. So now I have solved for this piece of this angle to be 75 degrees, 26 minutes. It's pretty jammed up in there. All right, if that angle has that angle measurement, then this angle, alternate interior angle, also has this measurement. So I can go ahead and solve for that azimuth. Let's do that first. By taking 90 degrees and subtracting that 75 degrees, 26 minutes. So we'll borrow from that, becomes 89, 60. 60 minus 26, 34 minutes and 14 degrees there. So, like we said, that's coming from the north and that's going to the west, and it is 14 degrees and 34 minutes there. All right, again, I knew this angle by figuring out that alternate interior angle and then subtracting from that total interior, taking that piece off so I could find that missing piece. And now just take 90 minus that to get that little angle in there, 1434 for that azimuth. And once I know the azimuth, right, I mean that bearing, once I know the bearing, I can find the azimuth. I look at my drawing here, 360 minus that bearing will get me to my azimuth. Oh, I'm sorry, I should have labeled this bearing. Bearing was what I found there. Now I'm going to find azimuth. So now it's 360 minus that bearing, 14 degrees, 34 minutes. We'll go ahead and borrow from there. So 59, and that becomes 60. All right, and then 60 minus 34 is 26 minutes. And then 359 minus 14, 5, 4, 3. So 345 degrees and 26 minutes, which makes sense. This is a big azimuth, right? It's practically going all the way to that 360 degrees. So 345 degrees and 26 minutes. So a little back and forth there, especially at the end, kind of had to use parts from both of those to get that to come together. But there's your full solution, just trying to get it all on one page. If you want to have a screenshot of that, finding bearing and azimuth. Again, you don't have to follow that exact procedure that I followed. You could use different angle reasoning, but that's one approach to solve for the bearings and azimuths on that closed traverse for homework problem 1.